My name is Doreen Druids. I'm with Pivotal, and I've got a couple questions here to sort of get things going, and then if we've got some time, hopefully we can open it up to the room.
I recently joined the RabbitMQ team, the core team, but before that I was sort of started with Rabbit about 4 years ago, just as a developer. Got really into Rabbit, then branched out into Kafka, so I became a RabbitMQ and Kafka specialist doing consulting, and then doing community testing on Rabbit, and got to know the team, and suddenly they decided I was worthy of joining the team, which I'm not so sure, but we'll see.
All right, and Carl is our returning panelist from last year.
That's right. Yeah, so I've been working with RabbitMQ for 10 years soon, maybe. And 7 years ago, I created CloudMQP. Yeah, that's one thing.
Michael.
Right. I'm Michael Titian. I'm a developer on the core team. I've been contributing to First Client Library since 2009, 2010, something like that. And RabbitMQ itself since 2013. Yeah.
Diana?
So I'm with Earning Solutions, and yeah, I've been working with RabbitMQ for about 4 years now. I started off working with just a team from Earning Solutions was working with Pivotal. So yeah, I used to work with Michael a lot, and Diana, and yeah, and I'm now team leader at Earning Solutions for Rabbit. Yeah.
All right, we're going to start off with kind of a big, broad question about, there's a lot of talk about cloud-native architectures and technologies these days. So what makes RabbitMQ still relevant today? And what makes it cloud-native or not? I'll pick on someone if no one jumps in.
You go for it, no.
All right. Well, I'm sorry, but I don't really understand what cloud native means. Pardon my ignorance. But if we assume that it means A, automation friendly, B, available in all kinds of clouds, for lack of a better word, infrastructure products, you cover more than 10, I think. Observable, again, not everyone agrees on the definition, but and yes, there is some work to do around scaling the various workloads. Yeah, we have improved a lot of things since even 3.6. I think in 3 out of 4 areas, it's there. There is also an ecosystem of projects, all kinds of tools, .NET, Java, Reactor, Python libraries. So there is an ecosystem on top of that. For a project which is almost 13 years old, I think that's pretty cloud native, but that's only my definition.
Yeah, I think based on the technology that's used to implement Rabbit, so looking at the Erlang distribution protocol, I think when you look at the cloud, some of the services which cloud providers promise, basically ease of scale, basically spinning up a Rabbit cluster is literally seamless. It's very easy, and I think that's the power of Erlang. So yeah, I think the backbone of Rabbit still makes it very relevant today in terms of cloud environments.
Anyone want to chime in on use cases, serverless, microservices architectures?
Yeah, I mean, Rabbit is just extremely flexible. There are other messaging systems out there, but there's none that are as flexible as RabbitMQ. You can get ones that are better at scaling, but as we've seen from CloudMQP's talk, most people don't need 1 million messages a second. They've got far fewer, and they actually benefit a lot more from the flexibility of RabbitMQ, because you can go with Kafka, but suddenly you've got a lot more complexity to deal with. Whereas with RabbitMQ, you get such great decoupling between your publishers and your consumers. It makes a lot of your architectural decisions simpler. It makes changing your architecture more simple. And with Cloud NQP, you've got it in the cloud, so you can take it with you in any cloud migration you go to. There's loads of automation solutions. It's coming to Kubernetes, so it's still extremely relevant.
Yeah, I mean, we have a couple of thousand of customers with different use cases, and it's everything from IoT implementations, it's to financial firms. It's so varied, the amount of cases we see. No one is doing the same with RabbitMQ, and it supports so many different use cases. Everything from high throughput to many connections to very complex routing of the messages. So it's much more versatile than many other messaging queuing options.
Okay, so we heard an update this morning about 3.8. It's been available for about a month. Of course, we want to make sure everyone here has got that high on their radar and they've taken a look at it. What are each of you, if you had to pick one thing in 3.8 that you're most excited about, and there may be some overlap here, that's okay. Don't need to all come up with something unique, but what are you most excited about that you're already playing with or are looking forward to using more? Jack, we'll just start with you and go down the line.
Well, I kind of like them all, to be honest.
You're going to have to pick one, Jack.
I would, quorum queues or single active consumer or the new observability features. I mean, quorum queues is really cool. We've had mirrored HA queues for a while now, and most people have been bitten by it at some point. And your replication protocol shouldn't actually make it less safe than using, reliable disks or something. So I think the quorum queues are a big improvement, and I think it's early days for quorum queues. This is the first iteration, and it's just going to get faster, better use of memory, and it's also opened the door. Now we've got a raft-based system for new queue types offering other replication sort of patterns. So I think quorum queues, because it's just the beginning. We're going to have more queue types probably in the future. So that would be mine.
Yeah, one thing I'm excited about is that quorum queues are much more network efficient, like Gerhard talked about in his talk, I think it was. Today we're paying a lot of money for the intra-cluster communication. When one message is published in one node, it has to be copied to all others and back and forth. It's a lot of traffic back and forth, and quorum queues solves that neatly. And then the other thing that the new Prometheus management observability that is much more lightweight, and for us to poll the management interface will also save us a lot of resources on our clusters.
Right, so I'm definitely going with monitoring, even though I appreciate a lot of work went into implementing Raft efficiently and then adopting it in multiple places, and I saw that firsthand. But one thing that was mentioned in Gerhard's talk is that once we introduced all those metrics and a way to easily deploy new clusters with Prometheus and Grafana and share those things, the rate of experimentation and change just blew up. All the way to contributing to Erlang, but there are certain things that I did not mention in my keynote. For example, in just a month we reduced peak quorum queue memory usage by 25%. So how did that happen? It's not because someone just woke up one day and like, hey, I have this brilliant idea. It's because Jack had a lot of load tests that had the monitoring hooked up, and we have noticed certain things, and Carl managed to correlate some things, narrow it down, try a few things, and boom, you have a 25% improvement. If we didn't have any metrics, we wouldn't have this improvement. So it's hard to underestimate the power of that, in my opinion.
It's a strong case, Michael. Ayanda, how about you?
Okay, I think speaking from the Erlang and Elixir community, I think looking at the quorum queues use case, I think we've now got a solid development framework which is based on Raft, the is it Ra or RA? Ra. Yeah, so the Ra library, I think a lot of developers can now take that and basically use that to build their own distributed systems. And in terms of a use case, they already have the quorum queues, which is already in production in some systems, right? So yeah, I think from the community, that's a very big contribution from people. So.
Okay, well, no one asked me, but since no one said feature flags, I'll put in a vote for the feature flags. Okay, let's talk a little bit about that upgrade process, because as we saw, with the data from the Cloud AMQP team, 2/3 of that sample size are on 3.7, but that means that there's still 1/3 of folks out there on older versions. Maybe, as you said, Anders, if it's not broken, why touch it? But there have been a lot of improvements in the latest releases and all this new stuff in 3.8. When looking at the upgrade process, what would you highlight for folks, either that you kind of know from past upgrade processes or things that are starting to change with the new features? What would you highlight for folks to help improve that process for them? Or any gotchas to avoid?
Well, one would be make sure you provision if you're running a cluster, make sure you provision it. If you want to use feature flags in the future and have a roll-in upgrade of your servers, if you can't take the loss of one node because you're already at capacity, then it's not going to go very well. So always make sure you've over-provisioned your cluster to cope with a loss of a node. I guess, Carl, you've probably got the most experience with upgrades with all your thousands of customers.
Oh yeah, we see that a lot. And it's a great improvement with the feature flags that we can now do rolling upgrades between minor versions. Still can't do it between Erlang or when upgrading Erlang, but that's not so critical. Historically, we always recommended customers to be sure to do a blue-green deployment, to have another cluster that they move over to, use queue federation to move the messages to the new cluster with the new version on. That's the easiest, often most reliable way to do it. Then they can easily roll back and all that. Our service, of course, provide automatic upgrades, and we can do rolling upgrades. But when you're at capacity, people don't realize that sometimes. Then that causes a big problem. They're already using, way too much resources. Then taking down a node, and then the load is moving to other nodes, the remaining nodes, and then they get overloaded, and then it's just a mess. And then the queue synchronization and all that, and hopefully that's better now with quorum queues. So.
Yeah, I don't really have much to add, and by the way, I completely respect the point of view that if something isn't broken, then you don't have to touch it. Just keep in mind that there is this thing called security vulnerabilities, and if you don't touch a system that is vulnerable, well, you're running a certain risk. And if you're a financial institution, that's probably also a regulatory risk. So, in my opinion, you can, with all of these improvements, which again, by the way, took a lot of engineering effort, you can always experiment with a blue-green upgrade, even on a loaded system, because you're bringing up something new. You switch half of your traffic over. If something goes wrong, you still have your original system to go back to. In my opinion, that's a very low-risk option. Again, I understand that it was difficult maybe a few years ago, where the degree of automation, various open source data services, was not necessarily at the same level. These these days a new cluster is like one API call away. So you can definitely try it. But of course, we would love people to adopt 3.8 sooner, and I think there is enough substantial improvements to make that appealing.
Okay, I think based on most of the customers that we work with, one of the most common requests is how do we upgrade with minimal downtime? So I think looking at the work that's come in 3.8, being able to do upgrades with mixed version nodes, I think that's a step in the right direction. Looking at what 3.7 brought in with the rolling upgrades, where nodes don't time out, right? Based on the ordering.
Random restart.
Yeah, random restart order. So I think looking at what each major version is bringing in terms of answering that question of improvements around upgrading, minimal downtime. Yeah, I think that's a really good addition in 3.8.
Okay. So our next question, we're going to sort of shift and focus in on a couple particular hotspot areas. Performance is one. What are some of the considerations or approaches that each of you take when thinking about performance and how to optimize for it? Let's start with you, Ayanda, and kind of work our way back.
Okay. So I think around performance, referring to the talk from CloudMQP as well, if you look at how users make use of a Rabbit node or a cluster, our approach is we've noticed that it's becoming a discipline in itself, being able to design and optimize the usage of a RabbitMQ cluster in the right way and according to best practices for optimal performance. So we've come up with some design approaches, so designing for memory, designing for disk usage. I guess probably need to blog about some of those things.
I'd love that.
Yeah, we read some blogs around that. Yeah, so it's becoming I guess a field of focus on its own. So yeah.
Michael?
So I'm not going to give a lot of recommendations, in part because Jack has a talk dedicated to that, in part because I don't know what your workload is like. But on our team, we believe that any performance optimization work should start with metrics, because even people on our team cannot just take a look at the cluster and immediately say what's going on, unless it's like a single queue cluster, which is a very infamous workload. RabbitMQ was not designed for single queue workloads. So certain benchmarks are bottlenecked on a single core. Once you understand that, using a node can use multiple cores usually, if you have more connections and queues, reasonably well. There is a doc guide on runtime tuning. You can optimize things that way. As far as go and multi-node, it's all about queue distribution and, data locality. And data locality is something that, because we implement protocols that kind of exist, they're not, at least not too vendor specific. It's a good question, how do we improve data locality? While still implementing protocols that a lot of vendors implement. And I don't know how many of you have been on a consortium or anything, but reaching consensus and changing things sometimes can be very hard, take a long time, or be even impossible. And it's not enjoyable, the process. So I think that's an open-ended question. What can we do to improve data locality in clients and at least some protocols, given that evolving protocols is very painful? And lastly, from quorum queues to internode communication, we keep eliminating certain bottlenecks that that shouldn't be there. They're just implementation details. But all of that is only possible because we have some data to work with, and so should you. When someone comes to me and asks, hey, how do I make my system, how do I improve throughput here? My first, I have 10 questions. Basically, tell me what your system does and why and what are the metrics. I cannot help you otherwise. And I think it should be telling that if people who develop RabbitMQ will ask for data, first and foremost, maybe your team members kind of should take the same approach.
I think we used to have a lot of performance problems, but in the last couple of years, RabbitMQ has improved a lot. Earlier it was much easier to get out of resources on a RabbitMQ cluster. Nowadays, it's mostly they're running out of memory. They're like having millions of unacted messages, or maybe too many connections. Or with the classic queues, it's easy to get out of memory, or in certain scenarios. Data locality has been a problem. It hasn't really been, it hasn't been very efficient at it. The clients don't know where to connect or connect to any node, and it might not be the master, so the traffic has to go through a lot of nodes and a lot of traffic duplication, which can be costly in public clouds. And right now, it's not so much to do about that because the clients are not aware where the queue master is. But as we've seen, most of our clients, they're not using high throughput, publishing a lot or consuming a lot. So normally we don't see clusters out of CPU. But if they're using some certain extensions like dead lettering, they're doing funny things like dead lettering a whole queue at the same time for some kind of schedule mechanism, and then they dump 1 million messages into another queue, then that can be a problem too, because then RabbitMQ does not have the normal credit-based system, or at least not used to. So then you can easily overload the cluster, and it's often kind of hard to see that you're doing that or where the problem is. But then you see it in the inboxes of the Erlang processes, the mailboxes there.
It's quite difficult to predict performance of RabbitMQ. Part of the problem is the number of features. We've got features that you combine with other features. You've got a bunch of exchanges that you can combine with different types of queue, and you can have different message sizes. You can have hard drives, SSDs. You can have some network latency or none. I mean, there's more configurations and feature combinations than atoms in the universe, probably. In the end, it's just combinatorial explosion of things. So, my recommendation is to use perf tests and try things out, because you might think, well, I'll just add, I've got one node now, I'll add another 2, and surely it will go faster. And that's not always actually the case. And it might go faster, but it's not necessarily going to be a linear improvement. And so, you can spend a lot of money adding more servers and faster disks and whatnot, but if you're not addressing the actual bottleneck for your particular workload, then you can be throwing money away and not getting the performance you expect. So the best thing is to use some kind of load tester like perf tests, measure your specific workload, and try and kind of customize based on that. And there's loads and loads of optimizations that you can do all over the place.
So one comment on the feature combination explosion. That's one part why we have a queue-type abstraction. And you can expect more queue types in the future, both to cover certain use cases, but also make them narrower. Quorum queue already doesn't try to do everything that original, that classic queues can, in part because we would have to give up some of the gains, but also certain features that just don't make any sense in the context of Rabbit. You can expect more focused queues like that, and the smaller the surface is, the easier it is to optimize. In fact, maybe that's what you start with, like we want to optimize for a certain case. So that's our new strategy, if you will, having one queue type with half a dozen properties. There are limits to how far you can optimize that. And some combinations honestly don't make sense. Like if your queue is both durable and exclusive, what exactly are you asking for? So it will, I think, naturally get better, or at least easier to make a decision like what queue type do I need as more queue types, as we ship more queue types.
Thank you. Let's switch over and talk a little bit about RabbitMQ clients. What can we do to make clients behave better? Let's start with you, Carl.
Well, one thing we see many clients or customers struggle with is when a node goes down. And normally, many clients have automatic reconnect, but some do not. And what to do when you get that exception. And what is a good reconnect strategy. And what to do with the messages that is coming that you want to publish. And so what we've seen other clients sometimes do in other message queue systems is that they have like an internal queue in the client, and then offline write it, even have offline support to write it to the disk, and then when the application comes up again, it reads from the disk and start publishing it if the server then is up or the cluster then is up. That's one area of improvement we could see in some clients maybe.
Yeah, so we call that feature client-side write-ahead log. So what happens is if a node fails, yes, you can recover. Well, most of the clients that I maintain, they can recover. Everything else, it's not my problem. But there is a window of time between recovery that you still have some events happening in your system. So your publishers need to be able to handle that. It's something like Project Reactor. It will do that for you. But Project Reactor only exists for Java. There is no Python version. So what do you do? So one design decision is indeed you can introduce basically a buffer in your client which accumulates messages, and then when connection restores, it just publishes them. There are several issues with that I don't know if we ever announced publicly. So one is you have to be mindful of how much memory you have, because at a certain rate or with larger messages, you will quickly run out of heap. Is it okay to drop data is another question. Is it okay to republish some messages, right? Not every operation is important. And lastly, speaking of cloud native, in a lot of modern environments, the use of local disk is either impossible or highly discouraged. So what Carl suggested, and I completely agree, it's a good idea, would simply not work in this brand new world of cloud native everything. So what do we do? It sounds like we need 3 features to address this. And you have to do it for every client. So that's more in air quote features than we have people on our team, unfortunately. I think that's the main bottleneck, but we will do it soon enough, starting with, I don't know, you use a lot of Ruby, right? Well, we can experiment with that, and you can talk through it, your own idea.
Okay, so with, I think the main gap which we've seen with Rabbit clients is most users, there's a knowledge gap in understanding the MQP protocol fully in order to use it according to best practice with a RabbitMQ instance or a cluster. So yeah, I think an improvement that can be done on clients is probably some more automation for users, right? Around things like connection pooling. So yeah, because TCP connections contribute a lot to the memory usage on the server, and if users don't have to always think about how can we efficiently create new connections, reuse connections, that could help. And I think automation around, I guess, setting up the internal fabric of a node, right? So which type of exchange, for example, and the bindings and the queues, how to set that up. So we've done some of this work with some customers, created an automation layer for them, and all they want is just to, just do a single function call, and behind the scenes, everything is set up for them. So yeah, I think if we can have things like this out of the box, that would be useful.
Jack, did you have any comments?
Yeah, I just think that most developers don't need to know about AMQP, and they shouldn't be forced to really know how it works. Most developers are very busy, and they just won't learn it anyway. So I think some libraries could probably be a bit more simplified, a bit more high level. Some of the, playing with some of the Python clients and trying to set up a nice asynchronous publisher can, all the callbacks can be a bit complex. So I think there's probably room for improvement for some of the higher level libraries to abstract AMQP maybe a bit more away and just simplify it for developers. I mean, that's for your average case. Obviously, there's going to be cases where you want to leverage the protocol and understand it for better performance, but I think most people don't need that level. So.
Some trade-offs to make there, but
always.
Yeah.
There's always a trade-off.
Okay, so let's step back and look at kind of the RabbitMQ community at large. And there's some things that work really well. There's probably some areas that things could work better. You can look at things by way of vanity metrics, or you can dig a little bit deeper. But how would each of you kind of rate or assess the health of the RabbitMQ community today? We'll start with Michael this time.
Sure. So 2 metrics that I use, because I'm constantly exposed to them, is mailing list activity and pull requests on GitHub. As far as I can tell, both are steadily growing, not very fast, but again, it's a 13-year-old project, so there are more people on the mailing list who are not on our team and still fairly active. That is a positive sign to me. That said, I think that Google Groups, the mechanism, so to speak, we use, a lot of people are not very happy with it. For once, it's a Google product with an absolutely awful search. Go try to find a thread from 5 years ago. Even if you know all the keywords, it just doesn't show up. I don't know what's going on. Maybe they don't store the data for that long. But Google Group search is absolutely awful. And I have to use it when, I have to dig up a link to an existing discussion almost every day. Another problem is that Google services are blocked for over 1 billion people. So we will probably introduce a separate sort of forum. The Google group is going to stay, in part because it does have a lot of content and discussions. But we will have something else with search, which is not embarrassing and that hopefully won't be blocked for a pretty substantial fraction of the Earth's population. And speaking of pull requests, I don't know, it greatly varies between projects. Some get pull requests every day, others relatively rarely, but I see a positive trend personally. Hopefully that's because it's easy enough to contribute, and yeah.
I think, from our side of Element Solutions, I guess that will come from our sales team and business development. Yeah, we've got some, I guess maybe we need to publicize some of those numbers at some point. Yeah, but there's a lot of inquiries around RabbitMQ. And most of these, I mean, if you do ask them, are they on the mailing list? Most of these are not even on the mailing list. So even outside the scope of the matrix which Michael and his team uses, there's still a whole lot more users who are getting in touch through different channels to get solutions.
Jack, Carl?
Yeah, I mean, from working as a consultant, I mean, going into a place, invariably they've got a messaging system in there somewhere, used to, a lesser or greater extent. And, the big names is RabbitMQ, Kafka, and the cloud offerings, and RabbitMQ is one of the big names and still is. I mean, it's used widely, so just based on usage, I would say it's...
Yeah, I mean, we see continuously growth as more and more people want bigger clusters and more customers, and new clients from all over the place. So it's definitely a popular product, getting so more and more. We have a Apache Kafka offering too, but it's not seeing as much growth as RabbitMQ, which can be on different reasons, but that's what we see from our perspective.
Okay, I'm checking the time. I see that we've gone a little bit over. Would it be okay if we open up for one question from the audience? Okay, do we have a question, burning question from the audience? Oh, I see a hand back there, a gentleman in the blue shirt or jumper or sweater.
Hiya. I was wondering if any of the panelists have an interesting story, mentioning no names, of a time where RabbitMQ has been implicated or has played a central role in a major data breach or security incident.
So I think the beginning of your question was cut off there a bit.
Yes, I was just wondering if any of the panelists had an interesting story about RabbitMQ being involved in a security incident.
Has RabbitMQ been involved in a security vulnerability or exploit?
Major data breach of some kind.
A major data breach? Is anyone aware of a...
We've never had a data breach, so I haven't heard of it either.
Well, you know what they say, if your monitoring always says that your system is healthy, you have broken monitoring. I can see some parallels. So on a more serious note, I'm the person who usually handles all the responsible and totally responsible security disclosures. We get a few of them a month, most of them are noise. Do I have any stories? Unfortunately not, for two reasons. One is people host RabbitMQ on site quite a bit, and they have zero incentives to disclose anything. Another reason is, unfortunately, due to pivotal security policy, we no longer can mention vulnerabilities anywhere unless all pivotal products that involve, in this case, RabbitMQ, are patched. And thanks to lawyers, that can take weeks. It takes days for us, or even hours, but it takes weeks for some other products, which means even if I had a story, but that thing was patched, I don't know how interesting it would be. If I had something relatively new, I cannot disclose it, so I'm sorry, but I'm personally not aware of anything where RabbitMQ would be specifically responsible, and the last serious vulnerability that I can recall was 3616, where there basically was a bug in MQTT client's authentication. That was embarrassing, but it was quickly fixed.
Okay. Thank you, everyone. I think we've got a little bit of a break before we come back into this room for the closing sessions.
Excellent.